everyone, welcome to an algebra video tutorial learning about exponential functions. We're getting close to wrapping this series up, but I wanted to take a video just to compare what we've done with linear functions and exponential functions and just compare and contrast the two, specifically in this case with a table of values. So here I've got two tables of values. I got f of x and I got g of x, and we're going to look at, well, which one is linear and which one is exponential, and how can we just tell the difference? Again, hopefully this is not a difficult thing at this point, so it'll be kind of a nice review, but it'll also help accentuate the differences between linear and exponential functions. Okay, the first thing I want to do is linear functions. When we think about linear, I'm going to write this out here. Linear means a constant rate of change. So we talked about constant rate, we talked about things like slope, constant rate, slope, and really the pattern for linear functions is we repeatedly add the same thing over and over again. Repeatedly add. Now let's contrast that with exponential. Exponential we had a common ratio, right? Common ratio, not common rate, common ratio, and we will repeatedly multiply to get the pattern. So exponential is all about multiplying. Linear is repeatedly adding. So if you want to tell the differences, look for the table that is repeatedly adding the same thing. And for exponential, we want to look for the table that's repeatedly multiplying by the same thing. So let's start by checking to see if they're linear. I'm going to start with this one on the left here. And to see if they're adding the same thing, we take the difference. So I'm going to take 106.5 minus 124. I'm going to check that with what is 89 minus 106.5. See what that equals. I'm going to subtract these two, 71.5 minus 89, and see what those equal. So let's just go ahead and just calculate these out now. 106.5 minus 124 means we had a change of negative 17.5. 106.5 minus 89, backwards, 89 minus 106.5 is also a change of negative 17.5. And 71.5 minus 89, there's another change of negative 17.5. So what we can see here is we're subtracting consecutive terms, right? I'm changing by 1 along my x values. So every time I change by 1, it looks like we have a constant change of subtracting 17.5. Well, what does that mean? We're repeatedly decreasing, we're repeatedly adding negative 17.5, the same thing over and over again. I could check these ones as well just to make sure. But this one is a linear pattern because we are constantly, repeatedly adding the same amount over and over again. Just for kicks, let's go ahead and subtract these ones, and we'll really quickly see that they do not have a constant. So let's take 115.3 minus 124. And 115.3 minus 124, and we get a change of negative 8.7. Let's subtract these next two. Let's do 107.2 minus 115.3. 7.2 minus 115.3. If I subtract those, we get negative 8.1. Let's do the next two. Maybe that was just a fluke. 99.7 minus 107.2. We subtract those, 99.7 minus 107.2, and we get negative 7.5. Well, just looking at these, negative 8.7, negative 8.1, negative 7.5, these are not constantly adding the same thing. Those are different values. Those are different amounts of change between each term. So this one is definitely not linear because I don't see the constant rate or constantly repeatedly adding the same thing. But we do have exponential, so let's check exponential out here. Exponential means I can divide two terms. I'll have a common ratio. So if I divide each consecutive term, then I should see the same thing over and over. So let's just check a couple here. Let's divide these two. So if I do 99.7 divided by 107.2, let's see what we get. 99.7 divided by 107.2 is 0.93. All right, let's divide these two consecutive terms. 92.8 divided by 99.7 and I get 0.93 again. Let's divide these two. 86.3 divided by 92.8 is 0.93. There we're getting some consistency, right? So whenever I divide, and if I get a common ratio, this consistent pattern, this ratio here, that is definitely cluing me in that we have an exponential function going on. So there we go. So this one on the right, function g of x, was definitely not linear. We did a few terms and saw that the constant rate, I wasn't subtracting and getting the same result. But if I divided consecutive terms, then I've got a nice consistent pattern showing me it's exponential. Just for kicks, on this one, let's go ahead and divide a few and just show that this one over here, we already showed it was linear, but f of x, we're going to show that it's not exponential. So let's divide these two here. 71.5 divided by 89, and we get a ratio of 0.80. Let's divide these two. 54 divided by 71.5. And I get 0.76. Let's divide these two. 36.5 divided by 54. And I get 0.76. No, 0.676. Sorry, can't even read my own calculator. So here you go. We can see that although if I subtracted, I got a nice constant difference of negative 17.5. But if I divide, things aren't constant at all. They're changing every time. 0.80, 0.76, 0.676. So that would clue me off that that is definitely not an exponential function. It's not fitting that exponential pattern. So this one on the left was linear, and the one on the right was exponential. And we look for patterns either by subtracting to see if they're the same or by dividing to see if they're the same. Hopefully that helps you understand the differences and better understand how linear and exponential functions themselves work in terms of repeatedly adding or repeatedly multiplying by the same thing.